When you want an AI model to respond using its existing knowledge in a new way, the best solution is to fine-tune the model. The downside is that fine-tuning can be downright confusing, frustrating even, and figuring out how to do it can feel impossible. Check this out though. Here's Ollama 3.1 answering a basic question about black holes. But here is a model that's been fine-tuned to answer like a pirate. Well, at least that version of pirates that we all know introduced by Disney in the 1950s.
But how would you feel to be going back to England to stand?
I have no system prompt set here. This is just how the model answers questions. We can get the answer to the meaning of life, or maybe even get this pirate to write me a tweet. I have fine-tuned this model using a tool called Axolotl. I've been doing a lot of fine-tuning over the last 3 videos. First, we looked at the general concepts of fine-tuning, then we got into MLX on the Mac, and the most recent video used Unsloth. They both have their strengths and weaknesses, and seeing Axolotl compared to the others will be interesting for all of us. By far, the easiest to use is MLX, but it's Mac only. You might think that Sloth has a stronger need for a developer background, but all the tools really need that experience to get the most out of them. Both MLX and Axolotl are commands that you run, but Python very quickly bubbles up to the top, and Python errors can very easily get super confusing and buried in a massive text. No matter what tool you use, having an AI model close at hand to help decrypt the errors can be very useful. I've found that DeepSeek R1 is a great companion, especially in combination with a tool like Perplexity. So in this video, I'm going to show you exactly how to fine-tune a model using Axolotl. Well, kind of exactly. I can't promise that it will run exactly the same way on your machine because Python. I ran into issues I haven't seen in any docs or tutorials because my Python environment was just a little different than others. This is a technical tutorial focused specifically on using Axolotl. At the end, I'll show you how to bring that model into Ollama. If you haven't watched my introduction to fine-tuning video yet, start there first. I'll link to it in the description below. But essentially it comes down to a few core processes. First, and this is huge, you need to come up with a good data set. This is what you're going to fine-tune the model on. The goal of the data set is to help tweak the weights and biases of the model so that when it's asked a question, it knows the format it is expected to answer with. And that is the main thing you're going to do with fine-tuning. Tuning the way the model answers the question. So you get the data set, you configure how the fine-tuning process works, and then you run it. What it's actually doing is, for the most part, a black box, and you don't really need to know the details. But at the end, you'll probably end up with a LoRa adapter. When this is combined with the model, then you can ask it questions. To get this into Ollama, you create a model file that points to the model and maybe also the adapter. Now, I had some problems getting that to work right, so I also used Axolotl to merge the adapter and the model. And then you run it, and that's it. So the hardest part of all of this is building the right dataset. I used an existing dataset to fine-tune the model to talk like a pirate. But unless you're running a Pirates of the Caribbean ride, that probably isn't going to work for you. So you need to come up with questions and answers that make sense for your use case, and come up with more of those than is probably comfortable to come up with. I'm thinking about creating a future video that just goes into building that dataset, since that is the same process no matter what tools you use. Before we start, make sure you have Ollama installed and running. Now, Ollama isn't required for the fine-tuning process, but it's how we're going to run the model after we've fine-tuned it. You'll also need Python 3.10 or newer. I think this has the same restriction as Unsloth, and it can only be 3.10. 3.11 or 3.12, since it uses the same underlying components. You should also have some basic command line experience. And finally, a GPU. For this one, nvidia is best, but AMD seems to be a working option as well. Axolotl works best on Linux, though on Windows it'll work with WSL or Docker. On Mac, some of it works, but not everything. But then again, if you're on Mac, you should probably stick to using MLX. But if you're on Linux and have one or more GPUs, Axolotl works great. And that is pretty magical because it supports multiple GPUs, and Unsloth does not. I'll come back to that later on. If you're following this fine-tuning series, make sure you're subscribed. I have so much more coming soon on more local AI topics that you just won't want to miss. Let's start by getting Axolotl installed and configured on your system. We'll use a virtual environment to keep everything clean and organized. First, let's create and activate our virtual environment. I'll show you the commands step by step. Now we have the same options for this that we had in the previous video, venv or conda or plenty of other tools. Now, I actually had a lot of trouble setting this up because Python environments and all are just so wonky and get out of sync so easily. So I'm just going to show what worked for me in conda. If you're using something else, you'll have to play with it all to get it right. This part can be tricky. When I used just the install that's on the website, almost nothing worked. And I had endless errors with mismatched versions, and it was just a mess. Let's start by creating the environment using conda create -n-ax, because I thought that was a nice name, Python equals 3.11. And then activate it with conda activate ax. Then I needed to set up Torch. So conda install pytorch, torchvision, torchaudio, pytorch-cuda, -c pytorch, -c nvidia. The -c's, I believe, are for setting up the proper channels. After setting up that virtual environment, we need to clone Axolotl from GitHub. So git clone the Axolotl repo, and I specified the folder to clone to as Axolotl. Now we'll install Axolotl using pip. So pip install packaging. Pip install -e dot for the current directory, flash attention and deep speed. Pip install -u git plus https, the peft repo. I also needed to install Jinja 2 to get it to work. So pip install upgrade Jinja 2 3.1.0. With all that done, we can now start working with Axolotl. Now the real power of Axolotl comes from its configuration file. This is where we define our training parameters and model settings. For this video, I'm going to work with an example in the Axolotl cookbook on GitHub. You can find that here. I've actually tweaked that a bit, and I have that in this repo instead. Now take a look at the pirate.yaml in the cloned directory. At the top is the base model we're fine-tuning. And then we have some config around the dataset and the template. So we're using Llama 3 chat template and the Pirate Ultra Chat dataset. Val set size determines how much of this dataset will be set aside for evaluation. Sequence length is the context size for the model. Adapter can be set to LoRa or QLoRa or blank to train everything. Rank, alpha, dropout are all LoRa hyperparameters. There are lots of articles that talk about what this means, including this one that's linked to in the Axolotl docs. In fact, most of the other config options here are standard options for all fine-tuning techniques that probably get into the weeds more than we really need to right here, right now in this video. One thing I do want to mention is gradient accumulation, because that was something I didn't really look into to understand what it was. Gradient accumulation is a technique to simulate larger batch sizes when training with limited GPU memory. The idea here is that instead of updating model weights after each batch, gradients are accumulated over multiple smaller batches before performing a weight update. This process effectively creates a virtual larger batch size while using less memory. Now, when I read up on this, I asked, well, what's a gradient? Apparently, a gradient is a mathematical measure that indicates how much the model's loss would change with respect to small changes in the model's parameters. Now, if you have 100 examples but only have enough memory to process 20 of them, gradient accumulation will let you train 20 and then save the gradients and then repeat 5 times and update the model when all 100 are done. So now we can run the actual fine-tuning process. Axolotl train./pirate YAML. The output for this command will look like something is going wrong, but it's all good until you actually see it fail. And it will probably fail at first until you tweak everything for your specific hardware and your specific OS. My best recommendation is to work with some other model to help figure out the errors and how to solve them, since most folks will have different problems than I did. How long will this take? Well, this was a much bigger fine-tuning job than I had done with Unsloth and MLX. The author of the pirate example said that it took him 6 hours on his machine. I have no idea what that machine looks like, but on my machine, with 8 H100s, it took about 10 minutes. So on your machine, it should take between, 10 minutes and 10 hours. At the end of this process, you should see some new files in outputs LoRa-out. The last line in the pirate config file was saved tensors. And because of this, we should be able to create a new model file for Ollama pointing to the model weights and the adapter, but I had a problem getting this to run. So I merged the adapter with the model first. Axolotl merge LoRa-./pirate.yaml. We don't have to specify the locations for anything, since it's all defined in the YAML file. That command added files to outputs LoRa-out merged. So now we can create a model file like this, which is in the repo. This took a while to get right, and that's one of those nice things about Unsloth. I had a lot of problems with the output, repeating over and over and over again in a loop. Eventually, I got the template just right with some of those parameters. So Ollama create, talk like a pirate, creates the new model, and we are good to go. So let's test it out with a few prompts to make sure everything's working as expected. And there you have it. You've successfully fine-tuned a model using Axolotl and integrated it with Ollama. Remember, the quality of your results will depend largely on your dataset, which we'll cover in a future video. We've covered setting up Axolotl, configuring the training, running the fine-tuning process, importing to Ollama, and I think all of that is pretty cool. I definitely prefer using Axolotl over Unsloth once you get it installed, mostly because of the massive speed benefit of using multiple GPUs, and there is still so much more to play around with here. Let me know what you think in the comments below. Are you interested in more fine-tuning content? This is the 4th one in a row, and each of them have been a big challenge to make. Well, thanks so much for watching this one, and I will see you in the next video. Goodbye.